Okay, hi everybody. In this video, I'm going to teach you how to write the molecular formula of an alcohol with 7 carbon atoms, and then we're going to draw and name all possible isomers. Okay, so 7. That means to say N is equals to 7. So let's take the general formula. That's CnH2n plus 1 and OH. This is the general formula for alcohols. So C7 H, 2 times 7 is 14 plus 1, that's 15, and OH. Okay, so this is the molecular formula of an alcohol with 7 carbon atoms. Now we're going to draw all possible isomers. So we're going to start with the longest carbon chain. I'm going to just draw one straight horizontal line. 1, 2, 3, 4, 5, 6, 7, and put all the H. Okay, there are altogether 15 H. Okay, and OH. Okay, so I'm going to put the OH at carbon number 1. Alright, so this OH is at carbon number 1. Now that's the first isomer. Let's look at the second one. Okay, I will move the OH to the second carbon. Alright, and all the others, we fill it in with H. Okay, to make this video short, I'm not going to fill up all the H. Okay, to draw the next isomer, I'm going to move the OH again. Alright, I'm going to move the OH again to the next carbon, which is carbon number 3. Okay, yep, that's another isomer. Now if I were to name them, this would be heptan 1-ol. This would be heptan 2-ol. This would be heptan 3-ol. Can I do a heptan 4-ol? Let's see. 1, 2, 3, 4. If I number it from the right side, it's also 1, 2, 3, 4. Okay, yes. So I can do a heptan 4-ol. 1, 2, 3, 4. Okay. So I just move the OH to the next carbon. Alright, and this is a new isomer. Okay, if I were to number it from the left, it will be 4. If I were to number it from the right, it will also be 4. Heptan 4-ol. Okay, now can I move the OH to the next C? Okay, looks like I can't, because if I were to number from the right side, okay, let me write it down here. 3, okay. So this is 4. If I were to move it, 1, 2, 3, 4, I move it to the next carbon. Okay, this will not be 5. This will not be heptan 5-ol, because the numbering system from the right side would make it a 3. So this is actually heptan 3-ol, which we already have heptan 3-ol. So this is not another isomer. Okay, so for the longest chains, okay, I can draw 4. And now let's go on to the branches. Okay, let's go on to the branches. So with this first heptan 1-ol, okay, I will shorten it and make one branch. Okay, let's try and shorten it. So this is the 8, 5, 6. Okay, this is the first isomer that we had earlier. Okay, I've shortened it down to 6 carbons. Alright, so that I can make a branch here. Okay, so this would be a methyl branch. Okay, a methyl branch. Yeah, so I would name this 2-methyl. Okay, now I have 6 carbons in the longest chain, so I would name it hexan 1-ol. Okay, I can also shift the branch to here, the third carbon, so this would become 3-methyl hexan 2 oh sorry, 1 is still 1 because the OH is still at 1. Okay, then I can keep moving. Okay, I can keep moving the C. Alright, sorry, this is supposed to be a branch. Okay, I'll move the C over. Alright, so this becomes 4-methyl. Remember, in our numbering system, we can only number it once. Sorry again. This one should be 1 because the OH is still at carbon number 1. Okay, so when we number the carbon long chain, we only number it once, and the functional group must take the smallest number. So it's 1, 2, 3, 4. So yeah, this is a new isomer. Yeah, I can keep moving it. 1, 2, 3, 4, 5, 6. I can keep moving it. This is 4. I can move the branch again. Okay, so this becomes 5-methyl hexan 1-ol. Now I can't move it again to the next C, because remember, branches, they are not supposed to be at the sides. Branches must always be in the middle. Okay, because if the branch is at the side, it's not a branch anymore, it will be a link. Okay, it becomes part of the long chain, so it cannot be at the side. Okay, so that's all I can move. But don't forget, I can also shorten it one more to make 2 branches. Okay, and I can shorten it again to make 3 branches. So there are actually so many options, so many isomers that can come out of this C7H 15OH. Okay, so now we look back at the first page. Now from this second isomer that we have written earlier, okay, we can create another branching pattern. Okay, so I'm going to use the second isomer that we have created and shorten it to 6. And now we're going to make some branches out of this. Okay, remember the sides, the 2 sides, we're not going to put any branch. We're going to put a branch here. Okay, so this becomes 3-methyl, okay, hexan 2-ol. Okay, I can also put a branch here. See, so many options to go. Okay, I can put a branch here, so this becomes 4-methyl hexan 2-ol. Okay, if I move it again, it becomes over here, this is 5-methyl hexan 2-ol, right? Or I can even put it up here, isn't it? 1, 2, 3, 4, 5, 6. OH here, I can put my branch up here as well. Okay, so let's count how many H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 H. Yeah. So there's 2-methyl, okay, hexan 2-ol. Okay. Now from the third isomer, I can also make my branches. Okay, so from the third isomer, I can branch out 1 here, and then 1 here, and 1 here. Okay, of course this is shortened already. From the fourth isomer, again I can branch out. I can shorten this, so I can take 1 C and I can branch, right? Of course your branches, they can also be double C branch, So there's so many options. Okay, like what I mean is this. Okay, if I were to take this C, okay, I cut it down shorter. This can be a double C branch, Okay, this is a branch, right? I've shortened it. Okay, if I were to shorten this can be a double C branch. Then again, no, because this is actually the longest chain here. Okay, so there are many options. So I want you to be systematic, alright, with your activity 2N. Be systematic and try and see whether you can get all the possible isomers. Okay, so what I've given you this example is on C7H15OH. The activity is asking for n equals to 5. Okay, not as complicated as this n equals to 7. N equals to 7 was so many possibilities. So you try n equals to 5, okay?